All right, so next up in Unit 4 is going to be Section 4.2, which is going to be us exploring different angle relationships. So we're going to split up 4.2 into two different subsections. So the first one will be us actually identifying what different angle relationships are. And then the second part, the second video, will be us actually utilizing those angle relationships in order to solve problems. So let's start with the different types of angles, okay? So I'm going to start by opening up this flap, just kind of show y'all that we've got this picture in the center. Okay, and I'm going to be using this picture to kind of show what the different types of angle relationships are that pop up. Okay, so let's start at the beginning. So we first have same side interior angles. Okay, you might also hear these angles called consecutive angles or consecutive interior angles, but they all mean the same thing. So same side interior angles are interior angles that are on the same side of the transversal. Okay, and it says we've got two sets in this picture, angles 2 and 3 and 6 and 7. So let's look at this picture. So same side interior. Okay, so in this picture, we have clearly labeled. We've got the interior, which is the space that is inside my parallel lines. Okay, so I've got M and N are parallel lines. They are never going to intersect with one another. And then we've also got this line A. A is known as my transversal. Okay, so my interior is the stuff inside the parallel lines. Okay, so if I'm talking about same side interior, all of my angles are going to be inside here. And then on the same side of the transversal, what that means is either they both got to be on this side of the transversal or they both got to be on this side of the transversal. So that's why for my same side interior angles, my pairs are going to be 2 and 3 and 6 and 7. And with each one of these angle pairs that we see, they're either going to be supplementary or congruent. And same side interiors will be supplementary, which means they will add up to equal 180. All right, let's look at the next one. Same side exterior angles. Okay, so similar to same side interior, same side exterior angles are going to be exterior angles that are on the same side of the transversal, and they also will be supplementary. So our pairs will be angles 1 and 4 and angles 5 and 8. So again, if we look on this picture, we have clearly marked that the exterior is the parts outside of the parallel lines. Okay, so if I'm looking for two lines that are same side exterior, they both got to be either on this side of the transversal or this side of the transversal, as well as being outside of the parallels. So that's why I've got 1 and 4 and 5 and 8. Those are my same side exterior angle pairs. And again, they are supplementary, which means their measures will add up to equal 180. All right, the next one I've got is alternate interior angles. So alternate interior angles are non-adjacent angles that lie between the lines on opposite sides of the transversal. These angle pairs are congruent, which means they are equal in measure. And my pairs in here are angles 6 and 3 and angles 2 and 7. So let's look at our picture. So alternate interior. So the interior part tells me that they must be inside the parallel lines. And then alternate is the opposite of our same side. Okay, so we talked first about same side interior. Now we've got alternate interior, which tells me that if I'm looking at that, they both got to be in the interior. One's got to be on this side of it, and one's got to be on this side of the transversal. So my pairs would be 2 and 7 and 6 and 3. Those are my pairs of alternate interiors. Okay, next up is alternate exterior. So alternate exterior angles are non-adjacent angles that lie outside the lines on opposite sides of the transversal. These angle pairs are congruent, and they are angles 1 and 8 and angles 5 and 4. So again, looking at our picture, alternate exterior. So we're looking at the outside space from the parallel lines, and we're also looking at opposite sides of the transversal. So I can have angles 1 and 8 are angles 5 and 4. And again, these angles will be congruent. They will equal one another. Okay? So next up, we're looking at corresponding angles. So corresponding angles have corresponding or the same positions relative to the transversal. And as you can see, we've got a lot more pairs here. We've got angles 1 and 3, 2 and 4, 5 and 7, and 6 and 8. And these pairs are all congruent. Okay, so the way I want you to kind of think about this. In this picture right here, let's imagine for a second that you decide to cut your picture in half, just like that. And then you decide to pull this piece on top of this piece. So if you do that, the angles are all going to line up with another angle. Okay, so if you push this thing over here, angle 1 would be sitting on top of angle 3. Angle 2 would be sitting on top of angle 4. Angle 5 on angle 7. Angle 6 on angle 8. These are our corresponding angle pairs. Okay, another way to think of it is if I've got these two parallel lines right here cut by a transversal, then if you look in the little groups of 4 that we have right here, angle 1 is in the top left corner. Angle 3 is in the top left corner. So those are corresponding. Angle 2 is in the top right. So is angle 4. Angle 5 is in the bottom left. So is angle 7. Angle 6 is in the bottom right. So is angle 8. So two different ways to look at corresponding angles. Okay, next up, vertical angles. So vertical angles are going to be two non-adjacent angles formed by intersecting lines. And as you can see, we've got a lot of pairs here too. Angles 1 and 6, angles 5 and 2, angles 3 and 8, angles 7 and 4. So with vertical angles. So we see in our definition that these angles are non-adjacent, meaning that they're not right next to each other. They do not share a side. So they are non-adjacent angles that are formed by intersecting lines. Okay. So with these, we're going to basically picture the angles that are opposite. They're directly opposite from one another. They don't touch each other, but they're directly opposite from one another. So for example, angle 1, it's touching angle 2 and angle 5, but it's directly opposite from angle 6. So angles 1 and angle 6 are going to be vertical angles, and vertical angles are congruent. So angles 1 and angle 6 will be congruent. Okay, same thing here. Angles 2 and 5. They're not touching one another, but they are directly opposite from one another. So they are vertical angles. We've also got angles 3 and 8 and angles 4 and 7. Okay, next up, linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. And as you can see here, they are supplementary. And we've got a lot of different pairs here. Angles 1 and 2, angles 2 and 6, 6 and 5, 5 and 1, 3 and 4, 4 and 8, 8 and 7, 7 and 3. Okay? So the linear pair. A linear pair is basically we are adding together both the concept of supplementary and adjacent. So supplementary being two angles that add up to equal 180. Adjacent being two angles that are right next to each other. Okay, so we're basically adding those two concepts together to create a linear pair. Another way to think of it is if you have a straight line, and then that straight line is cut into by one other line, thus creating two angles. Those two angles will make a linear pair. So that's why we have so many different pairs here, okay? Because if I just for a second just ignore this bottom half, okay, so I just ignore the bottom half. I've got 1 and 2 are sitting on a straight line. And I've got 3 and 4 that are sitting on a straight line. So because of that, angles 1 and 2 make a linear pair. Angles 3 and 4 make a linear pair. Okay, but again, if I now come at this line, angles 1 and 5 make a linear pair. Now, angles 2 and 6 make a linear pair. Angles 5 and 6. Angles 7 and 8. Angles 3 and 7, angles 4 and 8. So any pair of lines that are sitting on a straight line together, any pair of angles, that are sitting on a straight line together will make a linear pair. Okay, and then lastly, we have this last section called no relationship. Okay, so what I mean when I say that is these angle pairs we're going to talk about are still considered supplementary, but there is no one direct relationship to prove that they can be supplementary. Instead, we have to use a combination of the 7 that we've already talked about. So with the no relationship ones, we have 1 and 7, 5 and 3, 2 and 8, and 6 and 4. Okay, so let's explore how it is that we can show that these are supplementary and yet there's no direct relationship. So we'll just take this first one, 1 and 7. Okay, so we see in our picture, we got angle 1 right here, angle 7 right here. Okay, and as you can tell, there's really no direct relationship. Okay, one of them is in the exterior, one is in the interior. They're not in corresponding positions. One's on top of the transversal, one's below the transversal. So we can't really prove anything there, but what we can do is try to determine other relationships that we see pop up and then see if we can make it fit that way. So if I'm looking to try to determine how 1 and 7 can be related, I see, first off, that angle 1 and angle 3, they're corresponding, okay? So I can say that angle 1 is equal to angle 3 because they are corresponding angles, okay? I can now say that angle 3 plus angle 7 is equal to 180, and this is because they make a linear pair. Okay, so we talked about in the last unit that if we know two things are equal to one another, we can substitute them out at any time that we want to. So I said up here that angle 1 is equal to angle 3, and then I said right here angle 3 plus angle 7 is equal to 180. So I could just sub in angle 1 wherever angle 3 is and say that angle 1 plus angle 7 must also equal 180. And again, I don't have any direct relationship that is advocating for this fact. I had to use a couple different ones to show support for this. But this is how all of our no relationship angle pairs pop up, by doing combinations here. And again, this is not the only combination I could have used. I could have said 1 and 5 are a linear pair, 5 and 7 are corresponding. I could have said that. I could have said 1 and 2 make a linear pair, 2 and 7 are alternate interiors. Okay, I had a bunch of different ways I could have gone and proved that 1 and 7 are supplementary.